So this is the diagram which shows the operation of a basic biometric system, where you keep your finger and sensor actually senses your finger and it takes out the features that are required, and that is being put up in the database. That is enrollment. That is first phase is enrollment. Then next step is you do the verification. So you keep your finger on the biometric device, the features are being extracted, and the templates are being stored up in the database are taken out one by one, and it is matched by using the feature matcher. So it says whether the person is authenticated or not based upon the match. If it is matching, he is a valid user, or if it doesn't match, he is not a valid user. Third one is identification. So that is like I have told earlier. So verification and identification has to work in tandem. So after the feature extraction, here you give it to the feature matcher, and after n number of tries, you identify the particular user. So how do you see the biometric accuracy? So you never get an identical templates. So it's the most accurate one, because like you cannot take out a similar fingerprint. So each one is having a unique fingerprint. So you have problems of false match or false non-match. Like sometimes problems like for example, if you get your hand wet in the water and if you keep it on the device, it like some mismatch occurs, and sometimes even without that some mismatch happens. So that is usual, but the accuracy level when compared to other authentication systems are this is the most which is the most widely used, because they are having a higher accuracy. So if you see the graph, you in the axis you have the matching score, and now axis you have the probability density function. So you draw a graph to measure the accuracy. So you can plot characteristic curve, and we take a 2 million cross comparisons. So the iris, in the case of iris, there's no false match. In face biometric, it's the worst performer, and also we pick threshold balancing error rates. So if you see a graph, you have a false match rate on one axis, and another one you have a false no match rate. So the blue line is nothing but the false rate, and the white one is representing the fingerprint, the black ones represent the voice, the black dots, the white dots represent the fingerprint, and you have the hand, which is most probably like an hexagon shape, and you also have the iris, which is in the blue kind of representation. So we have the remote user authentication. Like example is a Google Gmail, where authentications over a network is more complex, and we probably have the problems of eavesdropping and replay. And generally we use a challenge response model, where the user sends an identity, the host responds with a random number r, the user computes the function f of r comma hp, and it sends back, and the host computers compares the value from the user with own computed value. If the match is found, the user is authenticated. So here this particular thing protects against a large number of attacks. This method is widely used. So what are the authentication security issues we have? We have the client attacks, host attacks, eavesdropping. Eavesdropping is nothing but hearing over something. A replay, Trojan horse, and the denial of service. So this is the practical implementation of user authentication. You can just go to the diagrams. Then I have given a case study. That's an ATM security. Here you have a model of security system that is developed in ATMs. So finally, we come to a conclusion that you can use passwords, tokens, and biometrics for the user authentication. And we have remote user authentication issues, and we have seen some examples and case studies. So hope you have learned some important aspects of user authentication. So thank you.